Hello, my name is Dr. Jeffrey Barsuk. I am the Robert Herstick Professor of Medicine and Medical Education at Northwestern University Feinberg School of Medicine. I currently serve as the Executive Medical Director of Northwestern Simulation. I would like to welcome you back to yet another podcast in our series on simulation and healthcare education. Today, we plan to highlight chapters 12 and 13 on mastery learning of surgical and bedside procedural skills and our book entitled Comprehensive Healthcare Simulation, Mastery Learning and Health Professions Education. Today, I have the distinct honor of interviewing Dr. Eric Hungness. Eric is the S. David Stolberg, MD, Professor of Advanced Surgical Education and Professor of Surgery and Medical Education at the Feinberg School of Medicine. He currently serves as the Surgical Director at Northwestern Simulation. Eric, it's an honor to interview you today.
Jeff, it's great to be here to talk about something that's passionate to both of us.
Can you tell me a little bit about your background? We usually start with that and a little bit more about how you got involved in simulation here at Feinberg.
Yeah, sure. Obviously, I'm a surgeon, did my general surgery residency, and did a minimally invasive surgery fellowship here at Northwestern. Been on faculty essentially since then. In the beginning part of my career, Deb DeRosa, a PhD educator in our department, asked me to be involved in the surgical skills curriculum that was ongoing and to try to make it a little more robust, et cetera. So that's how I kind of dipped my toes into surgical skills and simulation. And then through that process, just became more and more interested in it, saw the value of it, helping to help our learners decrease their learning curve or the time to get to the learning curve, and so that they can make the most impact once they get to the operating room. And then I'll talk to you about this a little bit later, but my interactions with Bill McGahey eventually led to me understanding and learning about mastery learning and our common duct exploration curriculum.
So thinking about simulation-based mastery learning and surgical skills, there isn't a lot out there in terms of projects that have been done. And of course, you mentioned your work with laparoscopic common bile duct exploration. I often think about the fundamentals of laparoscopic surgery or the fundamentals of endoscopic surgery in essence as mastery learning using simulation. What are your thoughts on that?
Yeah, I mean, there's the use of the quote-unquote mastery learning in surgery is not there, but there's a lot of experience using proficiency-based learning, and you can get into semantics of what is what and what really constitutes the difference between proficiency-based or mastery learning-based, and the fundamentals of laparoscopic surgery and the fundamentals of endoscopic surgery, those curriculum that you've mentioned, those are a national curriculum really focused on not only the technical aspects, but some of the didactic and some didactics as well, but really taking the most basic laparoscopic skills and having all residents have to pass this exam before going on. So it's a little bit different in that you don't know the cut points ahead of time, and there's not really a pre-test and then knowing that you've not met that mastery learning or the preset score. So there are papers out there that suggest that if I've met certain time requirements or certain proficiency, that you'll have 100% pass rate for this exam. So yes, it's proficiency based, but it's a little bit different. So much of what we'll talk about is in the deliberate practice with feedback from a coach. These basic laparoscopic skills for those really don't require a lot of hands-on coaching all the time. There's some initial coaching, but then it's really letting the learner go on their own. So there are some things that are similar, but some things that are a little bit different.
You brought up a very important point about terms that people often confuse. We talk about competency, which essentially is the minimum level that you can get by with to be successful at doing something. And then we talk about proficiency, which essentially is a very high level of competency. And people say, where does mastery fit in? And that the key point is mastery is a different concept in that when you're talking about the results of a healthcare procedure, it should be at a level of proficiency, but it's really determined by what your expert panel says during the standard setting. And I'm not really sure how they made these time cutoffs to determine the pass rate for the fundamentals of laparoscopic or endoscopic surgery.
Yeah, I don't know all those details either, and it's not only time based. There are some error based and some skills. So there's a formula, but again, that formula is not published, and so you don't really know what that is ahead of time. So again, it's a high stakes kind of blind exam. But you're right, it's a little bit different. I think the cut points are different. I think with the FES, you're just trying to almost it's not to that kind of quote unquote mastery standard, that higher level standard that we want. It's more kind of a gatekeeper sort of thing.
Got it. And again, although we hope that the mastery standard is very high at a proficiency level, we are at the mercy of our expert judges, so whatever they determine. But when we use the mastery angoff, as we alluded to in a different podcast, we usually get those very high score expectations. So let's start talking about the laparoscopic common bile duct exploration simulation-based master learning curricula, because in essence, it really was the first curricula to use simulation-based mastery learning in a real surgical procedure. And we talked about the Thomas and Kern model, which we described in podcast chapter 1, series 2. And if we could, I'd like to kind of have you take us through your curricula by using that model. As everyone will recall, that Thomas and Kern model starts with a general and targeted needs assessment. So in other words, why did you feel that the curriculum needed to be created, and why did you choose it?
Yeah, so the beginning of the laparoscopic common bile duct exploration curriculum really goes back to Dr. Fernando Santos, who spent some time in my research lab. At the time we were working on some innovation in the operating room and procedures, and he had he had just come out of the clinical realm and had a frustrating patient where he wanted to be able to do laparoscopic common bile duct exploration. So this was a really targeted needs assessment, but we started thinking about the more general needs assessment, in that ultimately the patients benefited from this because it would decrease their hospitalization by changing a two procedures down to one. The surgeon could do it all at the same time, reducing morbidity, complications, length of stay, and ultimately cost. And so while there was a targeted needs assessment, there was a more broad general needs assessment after we started thinking about it more.
Makes sense. And then, of course, your needs assessment led into your goals and objectives. And those are all very similar in simulation-based mastery learning, where you're required to meet a minimum passing standard. Did you intend to expand your goals and objectives early on to look at some of these clinical outcomes, or was it more, let's get our surgeons trained first?
Yeah, I would like to think that we set all these questions and goals at the beginning, but it did kind of develop more organically, and some of that stuff came a little bit later. There was an internal grant mechanism through our Department of Medical Education that we put in a grant application for after we came up with a curriculum on how to teach it. And this is where when another fellow, a research fellow came in, Dr. Ezra Teitelbaum, who really helped develop the actual curriculum. It was the feedback that we got from the reviewer process for that internal grant mechanism. And the feedback that we got was, hey, this is great, but you could make this a whole lot better. There's a concept called mastery learning, and there's this guy named Bill McGahey that you might want to sit down with to really kind of tweak your curriculum, just to raise the bar. And that set the stage for, like, it was eye-opening. It was, okay, let's set this bar high. Let's do this in the most excellent mastery way possible. So that was really how the simulation-based mastery learning component of it got borne out.
So how to write learning objectives is beyond what we're going to talk about today, but certainly the residents were required to meet a minimum passing standard at the end of the curriculum. And then you had a certain learning strategy, and it's pretty simple for simulation-based mastery learning in that, we give a pre-test, then we usually have some lecture or didactics of some kind, then deliberate practice, and then a post-test, and you keep taking the post-test again and again until you meet the minimum passing standard. But you had a unique problem in that there was no simulator available, and using cadaveric specimens would have been cost prohibitive, correct?
Right. And so just to make a reproducible model, like I alluded to, Dr. Santos, had started, building this model, and we kept refining it and getting better. Eventually, we were able to get it commercialized, and we got it commercialized. But after we proved that going through this curriculum, using the simulator could discriminate between experts and novices, we did the appropriate, validation work there, and that just made the curriculum so much better, because we had this model that would reproduce all the key components of it. Because it's a very complicated procedure, because you needed multiple views. You needed a camera view from the laparoscopy. You needed a camera view from the choledocoscope, which is the small camera that goes inside the bile duct. But then you also needed to do something called fluoroscopy. And fluoroscopy is radiation. We didn't want to use radiation, so we actually came up with a unique way of using mirrors and additional cameras to come up with a simulated fluoroscopy. And that was the main difference in the secret sauce of our simulator compared to a different commercially available one that just didn't serve our needs as well as we wanted.
Is your simulator available now?
It is. Again, it's kind of a niche thing, but recently there's been some advancement, and there's a commercial entity that's come out with a newer, better device on doing this, and they've actually adopted and purchased our simulators to train the next generation of surgeons on their equipment. So it's really great to see it now from where it started.
Yeah, it's been actually fun to watch the process from my bird's eye view, as well as I've seen you develop and get through the data on this project. Now, implementation is the next step in the Thomas and Kern model, and implementation and sustainability too seem to be one of the most difficult aspects at many institutions. How did you get this up and running and maintain it for all these years? Because you've been doing it for a while now.
Yeah, the main way I think our success has been just deliberately, saying that this is a priority. And embedding the curriculum within a rotation so that the residents, there's some timeliness to the curriculum. It's not just doing it at the beginning of the year and then maybe you're going to see a patient throughout the year. It's you do the curriculum while they're on rotation, so that they have a best chance of implementing it in real time. So I think that's been the success. Also, just the data and the improvement that we've seen in length of stay, and ultimately, for our patients, it's rewarding to see that. And then when the residents see that, they feel more empowered. They feel that they're doing the best they can for their patients.